Okay, the first problem number 4 is A minus 3B equals negative 22. The second problem is 4A plus 2B equals negative 4. Now, the problems you did with graphing all had X's and Y's in them. And you solve by graphing, and when you solve by graphing, you're trying to find an intersection point. I hope that was pretty easy. But can you imagine if the slopes got ugly or the y-intercepts were not easy to find? It might be pretty hard to solve by graphing. It might be pretty hard to solve by graphing if you don't come out with a whole number answer. So we have several other techniques. This is called solve by substitution. What do you think solve by substitution means? I am a substitute. I am taking the place of your regular teacher. Substitute is when something takes the place of something else. So we're going to let one variable take the place of something else. Now, I want to be smart about how I do this. I am looking for a variable with a coefficient of 1. What do we know the word coefficient? Coefficient is the number in front of the letter. So I'm looking for a letter that doesn't have a number in front of it, so that will be the coefficient of 1. That would be this one right here. Now, you're going to divide your paper into 3 sections to keep it organized. I'm going to choose the first equation. It doesn't have to be the first in order here. I'm choosing this equation because this has no coefficient written in front of it, so the coefficient is 1. And then I'm going to write the second equation in the second column. And then I rewrote the first one. So here's the equation I'm going to start with. I'm going to start and end with the same equation. I'll explain the 3 columns as we go. And then this one is going to be my substitute column. I am going to solve the first equation for A because that's the easiest thing to solve for. That means I have to get rid of this part, so I'm going to add the opposite. If I add a 3b on this side of the equation, I have to add a 3b on the other side equation. The reason I did that was so that this part would zero out. So we have A equals negative 22 plus 3b. If you wrote it the other way around, 3b subtract 22, that's okay. Either one of those would be a correct solving for A. Then I'm going to go to my next equation, and in place of this A, I am going to substitute this that I just calculated because this is equal to A. In place of the A, I'm going to put 3b subtract 22. I'm still going to have this 4 out in front. I'm still going to have a 2b, and it's going to be equal to negative 4. So I need to solve that. I solve that by distributing the 4. 4 times 3 is 12b. 4 times 22 is, that's a negative 22, so this is a negative 88. Plus 2b equals negative 4. Probably you were taught that I need to combine like terms. Those are on the same side of the equal sign, so we add the 12 and the 2 together and get 4b. Not 4, 14, what I wrote, not what I said. I am solving, so I need to cancel out the 88, so I'm going to add 88 to both sides. Those have opposite signs, so I subtract them and keep the sign of the largest number. To finish this, I need to divide by 14. Now, when you were solving by graphing, your equation is the intersection point. These are still lines. If I graphed them, I would still have lines, and my answer is the intersection point. But I don't have X's and Y's. I have A's and B's. So when we have other letters that are not X and Y, we put them in alphabetical order unless there's some kind of word problem and there's a context that would tell you to put them in different order. If you just have a problem without any words, you put them in alphabetical order. So we have found half of the solution. I haven't found all of the solution. In order to find the rest of the solution, I have to go back to this other column. I'm back to the problem I started with, and in place of the B, I'm going to substitute the 6. I have an A and a subtract 3 and a minus 22, and so I'm going to solve this one for A. 3 times 6 would be 18. To solve that, I'm going to add 18 to both sides. And A is equal to -4. These have opposite signs, so you subtract them and you use the sign of the larger number. If I graph these, I would find that the intersection point is at -4 and 6. The next problem is x minus 5y equals 10. 2x minus 10y equals 20. Now, they didn't give you a little chart on this problem. If you find the little chart is useful, then you can use the little chart. If it is not useful to you, you don't have to use it. But the chart has 3 parts. So I look at this equation and I try to find a variable that doesn't have a coefficient written down, because then that would mean the coefficient is 1. So I'm going to use this for my first equation because the coefficient here is 1. I write down the second equation, and then back to the original equation. Now, it just so happens that in the 2 examples I did, this was the first one and that was the second one written down. But this is the easiest one to figure out, and this is the second one. So it doesn't always have to be in that same order. We are going to solve this for x because that's the easiest thing to solve for. We're going to add 5y to both sides. X equals 5y plus 10. In place of this x, we are going to put the 5y plus 10. We still have this 2 out in front. Minus 10y equals 20. Distribute. 2 times 5, 2 times 10. But what happens when I combine like terms? What happens to a positive 10 and a negative 10? These zero out. Now there's two things that can happen when your variable zeroes out. It zeroes out, and is this true or false? True. So I don't need that equation. What that's telling me, when the variables zero out and I have a true statement, what that tells me is one line was exactly on top of the other. Did you see that in your graphing notes where one line was exactly on top of each other? So what kind of solution does that have? And that's what happens algebraically with algebra when you have one line exactly on the other. The last problem we're going to do is 2x minus y equals 5. 4x minus 2y equals negative 12. And so we're going to divide our paper into 3 columns. You don't have to use the 3 columns. It just can keep things organized. This is what we're going to solve for because the y doesn't have a number out in front. So that's going to be easiest. If I started to solve for x here, I'm going to get fractions. Do we like fractions? Probably not. So my first equation is my easiest equation. And then my second equation. And then back to the original equation. I'm solving for y, so I need to subtract 2x from both sides. Now, I have just made a major math mistake. Do you know what my major math mistake was? What kind of y was that? So what kind of y is this? So I'm not finished solving it. I need to divide everything by negative 1 to cancel out that negative. So y equals negative divided by a negative makes a positive, and positive divided by a negative makes a negative. So in place of the y, I'm going to substitute 2x minus 5. And I'm going to distribute that 2. I'm going to have a 4x minus 2 times 2 is 4x. And that's going to be positive 10 equals negative 12. What's going to happen to these? Those zero out. But do I have a true statement? If the variables cancel out and you have a false statement, what that's telling me is the lines were parallel. Do parallel lines cross? Do parallel lines have an intersection point? So what's the answer?